We'd like to do another one for good measure. Always with the step of 0.1 and then a step of 0.05 using Euler's method. So let's go over to MATLAB once again. Where's MATLAB? Right here. And let's do that. And let's not just reuse the code. Let's do a new code. So here I'm going to write chapter 2.6, exercise 7. This is going to go above, clear all output, all old variables. This is important. Then defining new variables. That's going to be sims x and y. And then here defining the initial conditions. So that's going to be y, the first y is 0.5, and the first x, well, let's define x first. It doesn't really matter, but I like to keep my things consistent, and that is going to be 0.5. So we have 0.5 and 0.5. I'm going to define a counter, so that's going to be n is equal to n plus 1, and then I'm going to define a step, and that's going to be h. We'll say we'll start with 0.1, and then I'm going to define the while loop. So that's going to be while, and then I need to give it a condition. And they tell us that they want us to find, okay, so I realized actually my starting x is 0, and they want us to get to 0.5. So while x of n is less than 0.5, do something and then end it. So what is going to be my do something? Well, I'm going to define the next y. And so that's going to be y of n plus 1. And what's it going to be? Well, it's going to be y of n plus h times the slope, where the slope is our function, which in our equation, differential equation, which is x minus y, all of that squared. Now, which x and which y? Well, the one that came before. This is the recursive nature of the problem. Now, we're going to update the counter. So n is going to be n plus 1. And now we're going to find the new x, which is really going to be x of n now, because n has been incremented, and it's going to be x of n minus 1 plus h. We don't want this to output either. We do want a plot of it, so we'll use scatter because we only have discrete amounts, so scatter of x and y at the end. And let's see if I forgot something or if this is going to give us something useful. So press Control Enter. The code is running, and it says, hey, I didn't recognize the variable n. Well, because when I define the counter, I define an increment instead of just a counter. That should make it work. So press Control Enter again. We did the whole while loop, and now we see something forming up here. We still don't have anything though. I wonder if we did something weird here. Let's see. We have our y. We have our y here. Oh, I think maybe because it doesn't like the fractions. So let's say that this should be double. That this should be double. And double just simplifies, approximates it. And this should be double. Well, this shouldn't really be double because, and so now we press Control Enter. We get our scatter right here, and then if we want to, we can go in the command window, input y, and these are our y values, and we can say double y so that it gives us actual numbers right here. And yeah, so this is how you do it in a nutshell, really, really fast. because we did it in slower terms before. And I hope this was useful, and I'll see you next time.